In this video, we're going to talk about how to factor by grouping four-termed polynomials that then have a second round of factoring by way of difference of squares. So if you've been given a question by your teacher that you're working through that has four terms, that you group it and then you realize that one of your factors or sometimes both your factors can be factored again via a difference of square, this is the question for you. So looking at this first one here, I have 2x cubed plus 4x squared minus 18x minus 36. What I'm going to do first is always look to see if I have a greatest common factor. In this case, our greatest common factor is 2. Because 2 is our smallest term, that's as big as our GCF could be. And 2 goes into all of our terms because they're all even numbers. What I'm going to do first is divide out a 2 from every term. Put it on the outside with some parentheses. Now I'm going to divide all these terms by 2. This first one would get x cubed. Next one would be 2x squared. Negative 18 by 2 is negative 9x. And then negative 36 by 2 is negative 18. So now I've taken out my GCF. I don't need to worry about this factor again until the answer. Now I'm going to look at what I have left in my parentheses. This is 4 terms here, so this would be done by a grouping. What I'm going to do is just group together my 2 first terms here, and then my second terms here. And remember, I'm going to look for my greatest common factor of each of my pairs of numbers. So my first pair here, my x cubed plus 2x squared, they have an x squared in common because that's the most number of x's they both have. And then my second pair here, notice this front term in this second binomial is a negative number. If your front term of any binomial or polynomial in general that you're trying to simplify by factoring is a negative number, you must factor out the negative sign as well, or take out the opposite of the GCF is another way you could say that. Both these numbers are divisible by 9. So now what I'm going to do is I'm going to go ahead and take out my GCF, put it out front for each pair. And now I'm just going to divide out my GCF. So x cubed divided by x squared right here in this first set is going to be x. 2x squared divided by 1x squared is going to be 2. So here in my parentheses, I have a binomial x plus 2. My goal, if I'm doing my grouping correctly, will be to have the same matching factor in my second pair. So I'm going to take out my negative 9. My GCF from the second pair. Negative 9x divided by negative 9 is positive 1x. Negative 18 divided by negative 9 is positive 2. So you'll notice here we have a matching factor right there. Now what we're going to do, just like if we were to do this with the box method, is we're going to divide out or factor out that x plus 2, which is our new greatest common factor. So I take out my greatest common factor of x plus 2 and then write down what we have left. So for this first set here, I would have an x squared left because I took out my greatest common factor of x plus 2. And for my second set here, I'd have a negative 9. Don't forget we're bringing down this GCF the whole time. Now from here, I'd ask myself, could either of my binomials be farther factored? And you may notice that this one right here is a difference of 2 squares. Our first one cannot be farther factored because nothing is squared, nothing is cubed. So this one here, x squared minus 9, this can be written as a difference of squares. So I'm just going to make sure both my numbers are written as squared terms. My first one's already squared. My second one said 9, you could say 3 squared. Now this looks like the format a squared minus b squared, which is the format of our difference of squares. And per this, it tells us that if we were to factor, we would end up with a plus b times a minus b. So I'm just going to go ahead and put it in that format right there. Here I would have my a is x plus b, my b is 3, times a minus b. Now I'm going to bring down my factors that couldn't be factored any farther. So my x plus 2, and then my original from the very top GCF here of 2. And this would be our final answer because these 4 factors, this is the final answer because these 4 factors could not be factored any further. Okay, we'll try the same thing for this one. If you want to pause and see if you can do it by yourself, I think that'd be wonderful. So our greatest common factor of this next one, we're always going to check for that first. It could be up to 3 because our GCF cannot be bigger than our smallest term. So the only options here are 1 or 3 because those are the 2 factors of 3. 3 does go into 3 and it also goes into 75. Remember, 5 25 times 3 is 75. So our greatest common factor is 3. And the very first thing I'm going to do now is factor out my 3. I will divide my 4 terms by 3, and you'll end up with x cubed plus x squared minus 25x minus 25. Now, I'm going to go ahead and worry about my polynomial right in here. This I can do a grouping on because it has an even number of terms. It has 4 terms here. I'm going to go ahead and group them like this. And then the first thing I'm going to do is find the GCF of each of my pairs. For this first pair here, we have x cubed plus x squared. They have an x squared in common. For my second pair here, we have a negative 25x and a negative 25. Remember, if the front term in your polynomial is a negative number, you must factor out the negative, and here they have a 25 in common. Now I'm going to go ahead and actually divide out my GCFs. So I'm taking out my x squared from this first pair, and then I'll take out my negative 25 from this second pair. So here, my first pair, I have x cubed divided by x squared, would just be x. And then I have plus x squared by x squared, anything divided by itself is 1. So inside my parentheses, I have x plus 1. If I do the problem correctly, I should also have x plus 1 right here in these parentheses as well. So negative 25x divided by negative 25, anything divided by itself is 1, and I still have that x left over. Here, negative 25 by negative 25, anything divided by itself is 1, so I have a positive 1. Now, remember the next step of grouping is to take out our matching factor. Here our matching factor, or our new GCF, is x plus 1. And then what I have left over, I have an x squared and the minus 25. And then don't forget, we still have our greatest common factor from the beginning. Now I ask myself, can either of my new binomials be factored any farther? This first one here cannot be factored as there is no squared or cubed or GCF to take out. Our second one here though, this is a difference of squares because we have a square term, a subtraction sign, and then this is also a perfect square. So I'm going to work through this one here. I'm just going to rewrite it so all my terms are squared. So x squared, and then instead of 25, I can put 5 squared. Now this is a squared minus b squared, just like the last question, and it can be rewritten, our format is right here, as a plus b times a minus b. So x plus 5 times x minus 5. And then don't forget to bring down the factors that we already have worked with that couldn't be simplified. And then our GCF from the very beginning was 3. And these is our answer. These 4 terms. Or sorry, 4 factors, I apologize. Okay, hope this helps. Bye. Good luck.